Today we'll be learning how to construct a Taylor polynomial as well as the Maclauren series. So when we're looking at the Taylor polynomial, first let's do the general series. And that would start out with f of c. C there is what you center your series at. Then continuing forward, you add the next term of the series, which is f prime of c multiplied by x minus c. This is all over 1 factorial, but since 1 factorial is just 1, it's not necessary in the series. Next, the third term would be f double prime of c multiplied by x minus c squared. Thus, all over 2 factorial. That is the third term. Now, a pattern comes about where you increase the derivative going from 0 to 1 to 2 to 3 of the f of c. Then you've got the x minus c, which increases in degree. Also on the bottom, you have the increasing factorials going through the series. From this, we can derive a general term, being sigma n equals 0 to infinity of f to the n of c multiplied by x minus c to the n over n factorial. This would be the general term for all of this. For a Taylor series, and a Maclauren series is simply a Taylor series centered at c equals 0. There you have it. So now that we know what the formula is for the Taylor series, it's important to look at an example of how to construct a basic Taylor series. For that purpose, let's look at the function of sine of x centered at x equals 0. In this case, we'll see that we have to start out by finding what sine of 0 is. Sine of 0 equals 0. Thus, the first term will be 0, so we skip that moving on to the second term. And next, we go to the derivative of sine, which is cosine, and we find to find the cosine of 0. Now, cosine of 0 is 1. Thus, we know that the derivative is 1. Moving on, we can derive the first term from that, which would simply be x, because as we see, the c is 0, so it's all that's left is x, and we're over 1 factorial. Next, moving on, we look at the derivative of that, which is negative sine of 0, which is once again 0. You can see a pattern coming about, as the next term would be a negative cosine of 0, finding that derivative. Except for now, instead of going right to that second term, to that third term, we go to the fourth term, which would be a negative 1 here, making it a negative x cubed. C still being 0, all that's left is x to the third in the next term in the series. But that is over 3 factorial, or 6. There you have the third degree polynomial of a sine of x function. There's a pattern arising here where it's an alternating series, which means that the general term would have an alternator of negative 1 to the n, or negative 1 to the n plus 1 in it. Thank you. So now that we know the sine of x function, as well as some other things important in Taylor series, let's look at 4 Maclauren series that are very important to memorize because they're very useful in calculus and are very applicable in many Taylor series situations. The first of which being the most basic, 1 over 1 minus u. This simply is u plus u squared plus u cubed with a 1 in the first term, and then going on a general term of u to the n. That's just a simple term from this, but the catch is that this whole series only works when its u is between 1 and negative 1. So now we'll look at the e to the u function, and that is basically 1 plus u over 1 factorial plus u squared over 2 factorial plus u cubed over 3 factorial, and so on, with the general term just being u to the n over n factorial. This is one of the most basic. Alright, so now let's learn the sine function, which is just the basic function that we've already learned, but I'm just going to write the series in general term right now. We start out with u minus u cubed over 3 factorial, then adding u to the 5th over 5 factorial. Going on and on until we get the general term of sigma n equals 0 to infinity of u to the 2n plus 1. Then we go all over 2n plus 1 factorial. Then we need to add an alternator, which is simply negative 1 to the n. The other option is negative 1 to the n plus 1. And that's now right now, since we're going n equals 0. Cosine function. And to start out that function, it's a little bit like this one, except for reversed. So instead of u, we're starting out with 1 minus u squared over 2 factorial, adding u to the 4th over 4 factorial. This sort of pattern goes on until we receive a general term very similar to this of sigma n equals 0 to infinity of u to the 2n over 2n factorial multiplied by the same alternator of negative 1 to the n. There you have it. The 4 main functions that you should memorize and learn. 1 over 1 minus u, e to the u, sine of u, and cosine of u.
So we're back, and we have these 3 simple functions here. We're going to go through them as fast as we can. E to the x, we are substituting the u in for x. So, like we had said before, you should have this one memorized. It's going to be 1 plus x, which is now it used to be 1 plus u, and now it's just going to be x. It's going to be substituted in for it, plus x squared over 2 factorial, and so on. We already know the general. So that's basically that function. All we're doing is substituting the u in for the x. The same goes for e to the 3x. Now pretend that your u is 3x. So it's going to be same thing, started out with 1, plus 3x, because that's now the new u, plus 3x squared over 2 factorial, which would eventually be 9x squared. Basically, in simple terms, all you're doing is plugging in this in the formula that we have set for e to the u, and making sure that it keeps going to approximate what we are going to x times e to the 3x. Just imagine that this x isn't here, so it's going to be the same thing, e to the 3x. We got 1 plus 3x plus 9x squared. This is just that simplified. Same thing over 2 factorial. Okay, so now imagine that we have this whole function, e to x times e to the 3x. Basically, having this on the outside of our function here just means that we're going to multiply it and distribute it into the whole approximator. So it'll now be x plus 3x squared plus 9x times x, which is just 9x cubed. That's basically how you do it. As long as it's on the outside, just distribute it into the inside. There's our approximator.
That Drew just went over is applicable to more than just e to the x. When we're looking at any function, going beyond the basics is important because functions vary in a variety of manners. So when we see a function of just putting the u as an x, that will apply for any function that you just substitute that x in for the u. When you have that x become a 3x or a 6x, just like that e to the 3x, you treat it as the u. Additionally, when you have anything outside the function, you look for that basic function, a function that you already know, and then you just add on to that basic formula, causing the insides to change slightly, but using it just as a multiplier or maybe something of that sort that would allow you to have a basic formula as a structure for forming your Taylor series. That allows you for many problems to have a very simple view of the problem and to very quickly construct a Taylor series in order to accomplish any task that you need. derivative of sine, which is cosine, and we find to find the cosine of 0.
Of sine, which is cosine, and we find to find the cosine of 0. So, the next term to know is e to the u, and that equals
Fuck something again.
fuck something again. Fuck something again. Centered at x equals 0.
All over 2m plus 1